Dear students, welcome to Physics Virtual Lab. Myself Ragi. Today we are going to do the second experiment of the series. Experiment 2. Aim. To measure the diameter of a given wire using screw gauge. Apparatus. Screw gauge, wire, magnifying lens. This is a screw gauge. Screw gauge is mainly used for precise measurement of diameter of a wire or thickness of a lamina. Screw gauge is also known as micrometer screw. It has got two scales. The linear scale, you can see this is a linear scale. We call it as a pitch scale. It is a millimeter scale. Each division corresponds to 1 millimeter. The other scale is the circular scale. You can see here the divisions are marked on it. It has got 100 divisions. One end of the U-shaped frame is attached to a stud and other end ends in a pitch scale. When the screw is moved forward, the stud and the screw together holds the object firmly. Theory. The pitch can be represented as pitch P is equal to distance moved by the screw divided by number of full rotations given. The least count can be calculated using the formula. Least count LC is equal to pitch divided by number of divisions on the circular scale. When the wire is placed between the face A and the face B, linear scale reading is equal to N. If nth division of circular scale lies over the reference line, then circular scale reading CSR is equal to N into LC, where LC is the least count of the screw gauge. Total reading is equal to linear scale reading plus circular scale reading, that is equal to N plus small n into LC. Now we are going to measure the pitch of the screw. For that, the 0 is on the reference line. It is coinciding exactly on the second line, that is 2 millimeter line. So I am going to give clockwise rotations 5 times. Five rotations over. Now this 0 is on the 7 millimeter line. So the pitch will be distance moved by the screw by number of full rotations given. So here the distance moved by the screw will be 7 minus 2 millimeter, that is 5 millimeter, and the number of rotations given is 5. So pitch of the screw will be 5 millimeter by 5, that corresponds to 1 millimeter. Zero error. In the first diagram, you can see the 0 of the circular scale exactly in line with the reference line. So 0 error is 0 and no 0 correction. Positive 0 error. In the second diagram, you can see the 0 of the circular scale is below the reference line. Here the error is positive and 0 error value is equal to circular scale division into LC. 5 is the coinciding circular scale division here. So 5 into 0.001 centimeter. 0 error is plus 0.005 centimeter. Hence the correction will be negative. 0 correction is equal to minus 0.005 centimeter. Negative 0 error. In the third diagram, you can see the reference line is coinciding with 95th division of the circular scale. So here the 0 error will be negative. And 0 error value will be 100 minus 95 into LC. That is 5 into 0.001 centimeter. Here the error is negative. So 0 error is equal to minus 0.005 centimeter. Since the error is negative, our 0 correction will be positive. 0 correction is equal to plus 0.005 centimeter. Now let us see what is the 0 error for this apparatus. So for that I am closing this screw, tightening the screw. You can see here the zero of the circular scale is below the reference line. Now let us see which line is in exactly line with the reference scale. So you can see that the first division is in exactly line with the reference line. So the coinciding division is 1. So our zero error will be positive. Zero error will be corresponding to 1 into LC, that is 1 into 0.001 centimeter. So zero error will be 0.001 centimeter. Zero correction will be negative, that will be minus 0.001 centimeter. Example. In the diagram you can see the linear scale reading is 6 millimeter. If nth division of circular scale lies over reference line, then circular scale reading CSR is equal to n into LC, where n, the coinciding circular scale division, is 70 here. So 70 into 0.001 centimeter, 0.07 centimeter. Total reading will be LSR plus CSR, that is n plus n into LC, that is 0.67 centimeter. And whatever be the zero correction, we need to add to get the final reading. Now we are going to measure the diameter of this given wire. So we will place this wire in between the stud and the screw. So we have placed in between the stud and the screw. Now we will see our pitch scale reading and the corresponding circular scale division. So here you can see that the pitch scale division corresponds to 1 millimeter and coinciding circular scale division So you can note down what is the coinciding circular scale division. Okay, so please note down what is the coinciding circular scale division and post your observation in the chat box. So this is your first observation. Let's see the second observation. For the second observation, I have changed the position of the wire. So now you can see what is your pitch scale division and your circular scale division. Please post your observation in the chat box. Just observe it closely. So please post your observations in the chat box. This is your second observation. Now for the third observation, I am changing the position of the wire and fixing it. Now you can see your pitch scale division and the circular scale division. Please note down your observation and please post your observation in the chat box. Observe your linear scale observation, then the corresponding circular scale division. This will be your third observation. And for the fourth observation, I am again changing the position of the wire. Closing it. So please note down your observation. Just take the observation for the pitch scale and note which circular scale division is in exactly line with the reference scale and note your observation. After that, please post your observation in the chat box. After this, we'll take one more observation. So I'll again change the position of the wire. Change the position of the wire. Now you can see Note down your linear scale division. This is your linear scale division and see which line of the circular scale is in exactly line with the reference line. This is 40 and this is 30. So your 5 observations are over, and now you cross check your observation with the observation table. Observation. Determination of least count of the screw gauge. 1 LSD is equal to 1 millimeter. Number of full rotation given to screw 5. Distance moved by the screw 5 millimeter. Hence pitch is equal to 1 millimeter. Number of divisions on circular scale is equal to 100. Hence least count is equal to 0.01 millimeter or 0.001 centimeter. Zero error is positive 1. So zero error will be 1 into 0.001 centimeter. Zero correction is minus 0.001 centimeter. Here correction will be negative. Table for diameter. Please note down your observation and please cross check your observation. The main scale reading for each observation is 1 millimeter, and check the corresponding circular scale division for each observation, and the final corrected reading is 1.37, 1.33, 1.38, 1.42 and 1.36 millimeter. Calculations. The mean diameter is 1.37 millimeter. Result. The diameter of the given wire is 1.37 millimeter. Precautions. To avoid undue pressure, the screw should always be rotated by ratchet R and not by cap K. For same set of observations, the screw should be moved in the same direction to avoid backlash error of the screw. Error due to parallax should be avoided. Sources of errors. The screw may have friction. The screw gauge may have backlash error. Circular scale divisions may not be of equal size. Points to ponder. What is zero error of a screw gauge? Why do we take number of observation for the diameter of a wire? What is meant by pitch of a screw? What is the principle of screw gauge? Thank you.